Yeah, today I'm going to talk about Elm. Elm is a purely functional language compiling to JavaScript, so you can build web stuff with it. But before I tell you a little bit more about that, then I'm going to talk a little bit about myself. Who am I? I ask myself that quite frequently. I'll tell you what I got though. My name is Tereza Sokol. If you're wondering why that sounds Czech, then that's because it is. I'm born and raised in Denmark, but my father's Czech, so yeah. It's nice to be home, I guess. I work at NoRed Inc. We're less pixelated in real life. We do like an application to teach children grammar and writing. Also, the guy who makes Elm is actually working there, so it's like the center of development of that. So it's like really cool. I got into Elm a year ago, almost exactly. I was big on React actually, and then I went to San Francisco for the ReactConf, and there was a lightning talk on Elm, and then I was like, wow, this sounds dope. And then, so my biggest take home from ReactConf was actually use Elm. So. And I did started using Elm a lot, and I was working on a website with a lot of charts, and then I realized that there was no charting library in Elm, and then I was like, okay, I guess I'm building a charting library. So yeah, I did that. That kind of taught me a lot about Elm as well. But today I'm actually going to talk about you and your developer experience. But by you, I mean about my developer experience, actually. And already now I can reveal that I think there are things we can do better, and I think Elm can do better about it. Like, it can fix it, I think, maybe. So yeah, I was thinking about how to describe this experience, and I think this one covers it pretty well, the street. So like, you start out, you have like a really exciting idea about your new app, and you create the folder, and you're like, wow, this is going to be so great. I mean, it's going to be the purest, beautiful application ever. And then like these 3 undefined dots happen, and then you're like, wow, I don't want to do this anymore. And if you live in a corporation, and if this is like your livelihood, this application, then you'll just go on without passion after this, which is like not cool. So it starts out with this promise. Like, yeah, like you're gonna make some really good stuff here, and so like I don't know what happens afterwards. I'm trying to figure out what these 3 dots were, and I think it's just unfortunate circumstances. And I don't mean like JavaScript. It's just that regular stuff like pressure from like a deadline, bad management. At least this is in a corporate environment. This is typically what's wrong. So like lack of team communication can cause you to write some bad code, and like maybe you're just like new on a team, maybe you're just having a bad day and you just want to go hang out with like your kids or staring into the ceiling like I do. This is like perfectly legit reasons to like skip over doing things in the right way. Like you like have a problem and you're like, you know there's a right way to do this, and there's a wrong way to do this. And you're like, whatever, I'm gonna fix it later. And this just leads to like more bugs, and like it would be fine if this just happened like once and then you were like actually fix it later, but it rarely happens like this. And this has some emotional consequences. For example, like these bugs in the first GIF is like they're like bugs from the past coming to punch you, and regrets, and like it can encourage, all these bugs can really encourage like the blame game on like your team, and you feel neglected and frustrated because all you do is like bug fixing, and then it shows up again and it's like, ah, no. Actually, like I've tried this. I worked at a company that like the whole application just like spread out terribly, like bugs everywhere, and we didn't get to do anything. We were 6 people in that team and everybody quit. Like everybody, like that's crazy. So yeah, we should try to avoid that. And that's what I want to like fix. So how do we do that? I'm not like the first one to suggest something to fix this. I mean, we have a lot of great libraries to like try to fix this stuff. Fix like, make sure that you don't end up in like situations where like prevent you from making bad choices, basically. And like, do these solve it? Yeah, they theoretically make things a lot better. Like, but the thing is that these frameworks and stuff like this kind of like ask you to close your eyes and be like, imagine a world where you cannot mutate stuff. And that's like, it works really well as long as you keep your eyes closed, but then when you open it and you're like, I want to go home, I'm just going to mutate this stuff. So yeah. So yeah, that didn't really work out. And I think we should just like try to ask ourselves, like, what are we even trying to do with all this like stuff? And I think it can be simplified a lot. So in web applications, we have usually like a state of some sort, and then we have some sort of view. That can also be like a function. And then usually when a user interacts with this view, there'll come like an event. And then what you really want is just like a function which takes the event and then creates a new state. And that's like, oh, we're done. Except also, of course, there's like other types of events. Like you can have like timers and mouses, like stuff when you want like somebody to come over and like poke you on the back and say something happened, please handle it. And lastly, also like asynchronous stuff like HTTP requests and that sort of event. And so you have this nice like architecture of stuff. And this is like, ta-da, it's the Elm architecture. Surprise. And you might be thinking, you can do that in JavaScript? And yeah, you can totally do that in JavaScript. You can do anything in JavaScript. That's the problem. So you can totally do this in JavaScript. This is basically just like React with Redux, and then if you want to do the type thing, then you can use like Flow or something, or like TypeScript. The point being that you don't have to. You can just kind of like skip over the parts where you end up breaking your application really badly and create a lot of bugs. So yeah. Elm does things differently. So basically what in this model, like what I'm trying to explain is that JavaScript has too much freedom. And what Elm does, it gives you some constraints. So let's take a look at these constraints. Since Elm is a purely functional language, you can only use pure functions. What does this mean? A pure function is a function which always has a return value, and this return value only is bound by the arguments, or like is made from the arguments that you pass it in. So it doesn't have any other contact with anything else, and it can't change anything outside its own scope. So like, this is a pure function, and like in pure functions you can, I don't know, fire missiles, doesn't matter, you can do whatever you want. It's JavaScript. Pure functions go hand in hand with immutability. And so if you see over there, there's a JavaScript example. So you initiate X with something, and then after you wrap it in this function, then it's like you have no guarantee of what X will be afterwards. Like, so that's like not cool. Well, that's like immutability. Well, in Elm, where you only have pure functions, because if you have it's a pure function, it can't change anything outside the scopes, then you know that X is like always unchanged. So it gives like a nice readability because you know things don't change out. Like imagine if that happened like your real life and you had like your keys in your hand and like all of a sudden it turned into a banana. It's like that's like not convenient. So besides that constraint, Elm also has a static type system, meaning that you just have to respect types. If you're thinking of Java right now, please don't run away. It also has type inference, so you don't actually have to write all these like type signatures. Although it's totally recommendable to do so though, because it gives like such a nice clarity of what your code actually does. So like you can do that, but that one's actually like really nice. These two combined has like no runtime errors. Like it's like what you do is like, so you have like the purely functional like approach. So you give the compiler a lot of information about how your data flows through your application, and you give from the static type system, it also knows like what kind of data goes through, and so it can like accurately interpret whether you will have a runtime error at some point. You know what this even like means? Like, it means no runtime errors. You'll never see one in your browser. Like, it's really great. And you're like, no runtime error? Seriously? How does it do that? Okay, so it has like really nice, this is like what will happen if you write a program, basically. So this is a tiny, teeny tiny program which has like a little, what we call a record in Elm Live, but it's really just like an object. And then, so all Elm programs starts with like a main, and then you can put your little object into a greet function, and then it's supposed to say come back with a string with the first name, but there's actually a typo, and the compiler will find that. Now, this in JavaScript, this will result in a runtime error, but in Elm, it will just tell you, and I'll give you like little hints on what you could have done wrong, and like, it's how cute. Okay, but really, no runtime errors? Like, yeah. There's a bunch of like companies who use it, including notoriously. We have like 100,000 lines of Elm code in production, and we have had no runtime errors to this day. So it's like pretty cool. It works. Another thing that comes from these constraints, which are pretty cool, is we can enforce semantic versioning. And it does this by the way, so when you have a package and you put it up to our package system, then the compiler can check like, okay, this is your API, this is like the functions you expose, this is the type signatures, so we could accurately like check if you, next time you change it and push up a version, you can check, okay, did these type signatures change? Are you breaking your API? And then like update it accordingly to the right versioning. So this way you'll never have like update with a patch and then end up breaking the API. So that's like really great. Also, it can improve performance in the way that when, for example, when you have the HTML and you have a pure function which makes some HTML, it can, because you deal only with pure functions, then you can see if the arguments haven't changed, then you don't have to render it again. So there's like a whole like world of not rendering. Wow. Also, like, there's a bunch of stuff you just get for free because like the static analysis that the compiler can do before you push anything to production, it can like go and check like, okay, is there functions that like you don't use, and just like, okay, we'll just not put this into the bundle. And there's like a bunch of stuff you can do to make things faster by just analysis that the compiler does. And this is like, you don't have to like go into Webpack and like do some crazy configuration to do that. It's just like, it's there, it just works. Also, that's like a really cool thing. It has the time traveling debugger, which comes from like the architecture that is like a unidirectional thing, and that is like purely functional, so you can always track it. I would totally show that to you because it's really satisfying to watch, but but I don't think I have time for that. But I'll show you if there is time. Also, there's like tailored syntax. So people are like really often to me like, oh, but you can do that in JavaScript. Why should I learn like a new syntax? But like functional programming works like has like a really, it's just beautiful. This is my personal opinion really, but it's great. So the situation is you have these constraints. It's only pure functions. You have a static type system. You're opinionated on your architecture, but you get all this great stuff like no runtime errors and enforce semantic versioning and improve performance and a time-bound debugger and tailored syntax. And people are like, yeah, but Elm is like so small. Is there any ecosystem? Yeah, it's totally going upwards. It's really great. And like, if you wanna, like, I know I'm asking you guys to like learn a new syntax and learn like a whole new world, and everything you did before you're not allowed to do anymore. But like, the whole point behind Elm is to sort of invest in the future and be like responsible about your code and just make it a little nicer. So I think it's worth it to invest in it, and you can also just build libraries yourself. Like everybody loves building stuff from scratch, right? It's amazing. Although if you can of course do like JavaScript interop with existing libraries. Like I also have an example that I can show you afterwards with where I implement the jQuery date picker in Elm, which is really not that hard. It's really silly, just use jQuery, you know. So yeah, I'll show you. It has it, and it's very easy. It's just like a line of code, and then you can use whatever libraries you want for JavaScript. You can have gradual implementation, of course. So like you can take your application with Angular and Angular 2 and React that you just learned about, and then put Elm in it gradually as well. Like, doesn't that sound appealing? So yeah, you can take like just like in React when you like take a node and say I want React in here, then you can do the same thing with Elm and be like, you can actually use like there is a React component where you can just put like a little bit of Elm like source in it, and then it'll just render it automatically. It's really neat. I can show you that as well afterwards. Again, I know I'm asking you, like functional programming, we really try to make it easy for everybody to learn. Like I was completely new to functional programming a year ago, and I thought that just the docs really care about documentation, and on Slack, like everybody is really nice. And you should totally, if you have any questions, you can just write. You can even like write to me if you want to. Like anything goes. And do we have time for demo? I have like 3 minutes left, I think. Okay, I'll show the time traveling debugger because that's like super cool. So can you see this? No, you can't actually. Huh. Can I like exit this? Am I not? That was a bad idea. Oh, it's here. Great stuff. Nice. So this is what happens. It's like, okay, so drink nice beer. Talk about this is done. And then you get like this little, and this comes with Elm. Like when you have like this platform and you run some Elm code, it just shows up if you're in debugging mode, and then you can just go through. Because of the purely functional, like the unidirectional, you can just, all the events are like tracked, and this is like not only satisfying, it's also really useful. Because you can import this little track of like messages that happened and export them, so like your QA guy can go in and be like, yo, this bug happened, that stuff is like a pixel wrong, and then send it to you, and then you can replay it, and then it's like, wow, I really see that pixel is very important. I will move it. And then, ta-da, you got it. So that's like really convenient. Also, do I have like a tiny bit of time now?
Yeah, you've got 5 minutes.
Oh, wow, okay. That's like a whole new world. I thought it was 20 minutes. Oh, nice. Okay. Elm is just so fast, you know? It's crazy. So I actually prepared this little, so I'm going to show you a little bit about the interop, because usually people are like mostly concerned about this. Because when you build like large applications, then usually like you're not going to build Google Maps right now in Elm. So this is basically an example of the Elm architecture. So it has like this, actually I'll show the result first. So this is what we're building right now. It's like a tiny little date picker here, and then the state is basically this state. And what's really cool about Elm, by the way, is that, you know, like, so you define the structure of your data over here, and maybe that's where the little monad pops out. So basically this means that it can be a string or nothing. And what's really, I'm going like off scope right now, but what I really like about Elm is like one of my favorite things is that it kind of really encourages you to think about your data structures, because it's like super obvious that you have to like define it very actively. So like I spent days at Neuralink just like writing like data structures, and it's that way. If you think about it for a really long time, your code just kind of becomes more elegant, because if you define it the right way with the right relationships to the different data you have, then it turns out really well. Anyways, so you have the update function here. This is like, I'll explain that later. So here you have the view function, and it looks, you can kind of like infer what happens here, I guess. So there's like a div and another div, and then it writes this text if there is nothing in the date, and the actual date if it does have the date. And then you can see this is the part we're looking for. This input field, which has like the ID date picker. And in my JavaScript, I have this little port here. This app ports, which is like the Elm ports. And it goes and finds this date picker and then adds, or this ID, and then adds the date picker in here. And then this is how the date picker, the jQuery communicates back to Elm. And on the Elm part, it looks like this. So this is the port where you're like, send down, oh, I wish I had more time, oh God. So this port is like, you send a command, which is like a message you send like to do asynchronous stuff. And then, so this one, when you send this one, which I do in the initial function, and then it comes in here and does this thing, and then whenever something happens to the date picker, then it sends it into this new date function, which comes in here, which ends up in the update with this new date thing, and then comes back, and then that's how you update your regular one. If you didn't understand that, then I don't blame you. But I would love to show you in real life. Where you can just come talk to me afterwards if you. It takes a little bit more of explaining, I guess. It's 20 minutes. I think that's probably it for now. That's why you should care about Elm. It's really great. Come talk to me. Does it surprise you?